Today on Astronerd, we're going to answer a question that almost everyone has asked at least once. Why is the sky blue? And while we're at it, we'll also answer another question. If the sky is blue, why is outer space black? To understand this, we need only three ideas. First, sunlight. Second, the atmosphere. And third, how light interacts with tiny molecules in the air. By the end of this video, the blue sky above your head will make perfect physical sense.
Let's begin with sunlight. When we look at the sun, its light appears white. So let's draw a beam of white light. Now, here's something important. White light is not a single color. It is actually a mixture of many colors. You can see this during a rainbow, or by passing sunlight through a prism. The white light separates into red, orange, yellow, green.
To answer that question, we need to talk about the atmosphere. From the ground, air looks completely empty, but it isn't. Our atmosphere is filled with tiny molecules, mostly nitrogen molecules and oxygen molecules. These molecules are extremely small, far too small to see, but there are enormous numbers of them. Every ray of sunlight entering Earth's atmosphere must pass through these molecules. Now, imagine one ray of sunlight entering the atmosphere. As the light travels, it encounters these tiny molecules. When light meets a molecule, a small amount of the light gets redirected. In physics, we call this scattering. The light is still there. It has simply changed direction. And this scattering happens billions of times throughout the atmosphere. Now comes the most important idea in this video. Not all colors scatter equally. In the 19th century, Lord Rayleigh discovered that the amount of scattering depends on wavelength. Mathematically, we write I is proportional to 1 over lambda to the 4th power, or I is proportional to 1 divided by lambda to the 4th. This means the shorter the wavelength, the stronger the scattering. Now, let's compare two colors. Red light has a relatively long wavelength. Blue light has a much shorter wavelength. According to Rayleigh's law, blue light scatters several times more than red light. So, as sunlight passes through the atmosphere, much more blue light gets sent in all directions. Red light mostly continues forward. Blue light spreads across the sky. Now, let's put everything together. Sunlight enters the atmosphere. The atmosphere contains tiny molecules. Those molecules scatter blue light much more strongly than red light. Some of that scattered blue light reaches your eyes. And because this scattering happens everywhere above you, the entire sky appears blue. You may notice a problem. Violet light has an even shorter wavelength than blue light. So, shouldn't the sky be violet? Not quite. The sun produces less violet light. Some violet light is absorbed high in the atmosphere, And our eyes are much more sensitive to blue than violet. So our brains interpret the scattered light as blue.
At sunset, sunlight travels through much more atmosphere. Along this longer path, most of the blue light gets scattered away. The remaining light is rich in red and orange wavelengths. That is why sunsets appear red. The next time you look up at a blue sky, remember what you're really seeing. You are seeing white sunlight interacting with billions upon billions of tiny molecules. The sky is blue because the atmosphere scatters blue light more efficiently than the other colors. The color above your head is not painted there. It is physics happening in real time. And perhaps that is one of the most beautiful things about science. Ordinary sights often hide extraordinary ideas. And this is Astronerd.